Okay, welcome to class. Everyone calm down here, listen up. Everyone paying attention. Devin, let's turn off your headphones. Serge, listen up, face the front. Okay, now that I have everyone's attention, we're going to start the class. First of all, I want a big thank you for Mr. Sinclair for filling in for me today. Let's give Mr. Sinclair a thumbs up. We don't need to yell and scream, but give him a thumbs up. Okay, thank you, Mr. Sinclair. Appreciate it. So we'll start our day with our puzzles as we always do. Actually, you know what? I don't think that's a good idea. The last thing I want is Mr. Sinclair to have to deal with you guys all yelling and screaming. So, Paul, I'm sorry. I know you take this pretty seriously, but we won't do the puzzles today. So there'll be no candies awarded. But I tell you what, if you guys are really good for Mr. Sinclair, he can give each one of you a Werther's or a chocolate, not both, at the end of his time, if he wants. Or maybe he wants to pass that obligation off to Mr. Lazan, who will also be coming in today. 2 teachers to fill in for me today. Alright, so no puzzles. Well, maybe just one. What's the answer? What's the answer? Alright, sorry Mr. Sinclair, I'm sure everyone's yelling and screaming. You know the answer. Let's move on. Alright, so we're going to do a little bit of review, some review from last week, then some review from earlier in the course, and then after that, you're going to do some homework, because that's what it's all about. And you know what? You could get this homework done in class. That way it's not homework, it's classwork. You should be able to get it done for sure. Then you'll have no homework for the long weekend. Won't that be nice? Alright, so we're going to look at, first of all, adding and subtracting polynomials. Tell you what, I'll highlight it for you so you can see what I'm talking about. Adding and subtracting polynomials. Yes, that's me writing that right there. Pretty cool, right? Alright, so what we have here is a whole bunch of monomials and we have to combine them. And as you remember, we can only combine like terms, right? They have to exactly the same variables, the letters, and the same exponents. And some people are getting confused thinking you had to change terms here and everything. No, that's only when we're subtracting polynomials, like over here, right? There's a subtraction and we have polynomials. So here you're not going to change any of the signs. All you have to do is combine the like terms. So there's 2 ways you can do this. One way, which I enjoy, because, it suits my lazy nature, is I just do some underlining. So if I was going to combine my x squareds, I would combine 3x squared and negative x squared. Remember to always underline the sign in front of it. But the other way you can do this, and maybe I should have made more point of this, you could rewrite all of these monomials in a different order. So I could write 3x squared and then minus x squared. Sorry about that terrible 2 there. Right? I could do that. And then for the x's, I could put plus 2x, remember to take the sign in front, and minus 6x. And for the y's, well, I think I only have one y. It's minus 9y. And for the constants, I have minus 4 and plus 4. So, maybe that's a good way to start. Some of you I notice have already been doing that, which is great. You don't have to do that. But if you'd like, if you're having troubles with this, I don't think many of you are, to tell the truth, you can rewrite it like this, and then you'd be combining these terms, there's only one of these, and combine these terms. Alright? Or do it the way that I think most of you have been doing it, and the way I do it is just do your underlining up here. So I have 3x squared take away x squared. Remember, what's the number in front of this x here? There's a 1 there. So we have 3x squared take away 1x squared, which equals 2x squared. Okay, now I'm going to underline the x's. The next thing I'll do is the x's. So I have positive 2x and negative 6x. Positive 2x take away 6x. Well, 2 take away 6 is negative 4. So I put minus 4x. Next I do my y's. What do I have for y? I have negative 9y and nothing else. So I put negative 9y. And finally we do the constants. We've got, gosh, I guess I'll do double wiggle underline or something. Negative 4 and plus 4. Negative 4 plus 4. Well, negative 4 plus 4 is 0. So should I put down plus 0 here? No, not necessary. If it's plus 0, it means it's plus nothing. So there's no need to put it. And this is your answer. Okay? So we did that last week. Hopefully that's familiar to you. So if we have a question like this, it's virtually the same, right? We're just adding two polynomials. What kind of polynomial is this? Go ahead, say it out loud. Trinomial, that's right. And what type's this? It's another trinomial. So if we're doing this, we're virtually doing exactly the same thing as what we're doing up above. There's really nothing different. So I'll do this super fast, and I'll just do it with my underline method. 5x squared. And actually, you know what I'll do? Mr. Sinclair is going to hit pause on the video right now, and you're going to just scratch this answer down somewhere on the side of your book or on your arm or on your neighbor's. No, don't do that. Okay. But anyway, just pause the video here, Mr. Sinclair. Give them, let's say 37 seconds, and they'll write down the answer to this. If they're really speedy, they can do this one as well, but I'll do this one in a second. Okay, ready, go. And welcome back. Okay, so I hope you found the answer that I'm going to get. 5x squared and negative 8x squared. Well, 5 plus negative 8 is negative 3x squared. Then I'll look at the x's. I have negative 3x and another negative 1x. Negative 3 plus negative 1 is negative 4x. And finally, I have positive 7 and positive 6. Positive 7 plus positive 6 is positive 13. All right, hands up who got that one. Nice. And honestly, who didn't get that one? That's okay. That's okay. And hey, Priya, why aren't you voting? Come on, Priya. Everyone has to vote in this. So this is the right answer here. All right, this one is pretty well the same thing, except one difference. There's a takeaway here. Subtracting polynomials. Tell Mr. Sinclair our one-word procedure for subtracting polynomials. The one word is don't. That's right. We don't want to subtract them. So what are we going to do instead? We're going to add, but we're going to add the opposite. Add the opposite. You have to do the opposite of everything here. So this is going to become a positive 3x, and this positive is going to become a minus 4. If you want, you could rewrite the whole thing. It might be safer, but I think most of you just do what I do and slap in the signs here. Okay, now this one here is adding, a plus. Should I also change these signs? No, because it's a plus. We're happy with our addition. How about the first one? Should we change that? No. When would you change the first one? If there was a minus out front, then you would change this to plus and the minus plus there. But there's not a minus out front, so let's just leave it. All right, now it's just like what we did before. We have 5x plus positive 3x plus negative 2x. So we're combining three things here. 5x and positive 3x is 8x, plus negative 2x is 6x. Oh, and you already did this one, didn't you? Okay, well just wait. We're going to get the answer in a second here. Be patient, Owen. All right, here we have negative 2, and then plus negative 4, and then plus positive 6. So negative 2 plus negative 4 is negative 6. And then plus positive 6, well, negative 6 plus positive 6 is 0. So that's it. There's nothing left to write down. You're not going to put plus 0, so your answer is 6x. Ooh, does that bother anyone, having a different color circle? Kind of bothers me, so I'm going to get rid of that. Ooh, just can't stand that. There. Okay, on to something completely different, but something I think you guys have mastered already. Multiplying and dividing integers. We are now going to start multiplying and dividing polynomials, right? We were adding, subtracting before. Now we're going to multiply and divide polynomials, but I don't want to get totally into it today, especially because I'm not there and I don't want to leave Mr. Sinclair with something new to teach you. So we're just going to do some review, get us all set up for it for next day. So multiplying and dividing integers. You know this, negative 4 times negative 5. You have two negatives, and when you multiply, it's everyone's favorite integer rule. Two negatives make a positive. So the answer, I'll call out someone. James, negative 4 times negative 5. James? Attaboy, positive 20. He got it, right? I think I heard him say positive 20. Next, Brian, you want to take this one? It's negative 7 times positive 4. Take your time, Brian. One negative and then a positive. So is it positive or negative, Brian? Yeah, it's negative. 7 times 4? You got it, right? Yes. All right. Nice job, Brian. Okay, next question. Hey, there's nothing between these brackets. What does that mean? It means multiplying, right? Negative 3 times negative 2 times negative 1. So if we multiply three negatives, a negative times a negative times another negative. What's it equal? Positive or negative? Negative, right? Two of them equal a positive. Multiplied by another one, you got your back to your negative again. And then we just have to do 3 times 2 times 1. And I know Mavis has this one. Oh, so fast. Good job, Mavis. 6. Yep, so negative 6 is our answer. Okay, negative 8 times negative 1 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 times positive 2. Wow. How many negatives is that? 1, 2, 3, 4, 5, 6, 7. This is not a negative. So 7 negatives. It's going to be positive or negative? Negative. What's 8 times 1 times 1 times 1 times 1 times 1 times 1 times 2? 16, right? So negative 16. Okay, so basically just remember the rule for multiplying and division. Hey, I never did division of integers. What am I thinking here? Same rules, right? Sorry about that. I forgot to give us some questions. If it was negative 8 divided by negative 2, answer is negative divided by negative, positive 4. And if it was negative 20 divided, remember I can write division like this as well, divided by positive 4, what's that equal? A negative divided by positive is a negative, and it's negative 5. Okay, breezing through that. Next thing and last thing I want to review today with you is the exponent laws. We did this earlier in the year. There was more than 3 of them, but I just want to cover 3 of them. Product rule, quotient rule, and at the bottom here we've got the power rule. So the product rule. What's product mean? That's when you multiply two things together. So in this case we're going to be multiplying powers, like 7 to the 4th power times 7 cubed, 7 to the 3rd power, right? And we had a rule for this when they have the same base. The base is the big number. 7 and 7 are both bases. 4 and 3 are called the exponents. So what's the rule when we have the same base and we're multiplying? If you forget, I'll give you a very, very quick rationale for the rule. What's 7 to the 4th power mean? What's it mean? It means 7 times 7 times 7 times 7. Remember, the dots mean multiplication. And then what we're doing is we're multiplying that by 7 cubed. What's 7 cubed mean? 7 times 7 times 7. So basically what we're doing here is 7 times 7 times 7 times 7 times 7 times 7 times 7. How many 7s are we multiplying together? 7 of them. We're doing 7 to the 7th power. What was our fast way of coming up with this number, right? Well, I just got rid of it practically. I don't want to have to do all this step here. How do I get that 7 that I've circled there? All I have to do is add the 4 and the 3. So that's the product rule. You just add the exponents. You can only do this if the bases are the same. The base stays the same, you add the exponents. So if we were doing this question, 8 to the 8th times 8 cubed times 8. All I have to do is keep the base the same, 8, and add the exponents. So when you add the exponents, what do you get? Oh, someone in the back corner there? Who was that back there? Someone said 11. Why are they incorrect? Because there's actually a 1 here. And 8 plus 3 is 11, but plus that extra 1 is 12. You get 8 to the 12th power. Oh my gosh, I forgot to circle. It's a mathematical faux pas. You must always circle your answers. Okay, this last question here in this section. What's the base in this case? The base is negative 10. So the base is going to stay the same. It's going to be negative 10. And you should keep it in brackets. Okay, that's very important. I won't get into the reasons why, although we did talk about that a lot. And then what we have here for our exponents is 6 and negative 3. What do we do? Well, let's go back and look at the rule. We're going to add the exponents. So our exponents are 6 and negative 3. We have to literally add 6 plus negative 3. Serge? Yeah, 3. Can you say it with a little more enthusiasm, Serge? Okay, 3. So negative 10 cubed is our answer in this one. Quotient rule. I bet you remember what happens, but hey, I'm on a roll here. Let me show you again. Let me prove it to you, not prove it, but let me demonstrate the quotient rule again. 12 to the 6th divided by 12 to the 4th. I can write that another way, can't I? I can go 12 to the 6th divided by 12 to the 4th. Exactly the same thing. Now, what does 12 to the 6th mean? It means 12 times 12 times 12 times 12 times 12 times 12. And 12 to the 4th means 12 times 12 times 12 times 12. So remember what I can do now? If you have the same thing on the top and the bottom of a fraction, you can Ninja slice! Hiya! Yeah! You might have to explain that one to Mr. Sinclair. But anyway, ninja slice. You can ninja slice top, bottom, right? There you go. 12 divided by 12 is actually just 1. You just got rid of 1 there by ninja slicing. You can do it again. Hiya! Hiya! Just got rid of another one. Again. Wah, wah. And one more. And so what we're left with is 12 times 12, which is the same as 12 squared. So I ask you again, how could we very quickly have come up with this number and not done all this? Because that just takes too much time to write all that out. Well, we could have taken our 6 and our 4, and we could have subtracted. That's our rule this time. Subtract the exponents. Oh, no one's writing this down anyway, so I can just scrawl it, right? Subtract the exponents. So in this one, oh my gosh, look at these negative exponents. Scary. That's okay. Just follow the rule. Keep the base the same. So the answer is going to have 6 as the base. And then we have to do negative 2, take away the other exponent, which is negative 6. Take away negative, oh, that sounds really difficult. What's our one-word rule when it comes to subtracting integers? Don't. There it is again. Don't. We need to add the opposite. So negative 2 plus positive 6 is positive 4. Our exponent is 4 here. There's your answer. And one more, just showing you can combine rules in the same question. So we have multiplication and division. There's our division here, right? So at the top in the numerator, we have 11 to the 10th times 11 to the 8th. Well, we're going to add those and get 11 to the 18. And then we're dividing that by 11 to the 6. Don't divide 18 divided by 6. If you think it's 11 to the third power, or 11 cubed, you're wrong, because you are going to subtract the exponents. 18 minus 6 is 12. 11 to the 12th is your answer. Okay, last rule is the power rule. I know you want me to demonstrate, right? You don't want me to just give you the answer. You want me to demonstrate. I will, just for you people. There's 2 ways to demonstrate it, but I'll just do one. We're going to do 5 cubed squared. What does that mean? Well, when you square something, it means multiply it by itself. So that would mean 5 cubed times 5 cubed. But wait a minute. What's 5 cubed mean? That means 5 times 5 times 5 in the first one times, what's 5 cubed mean in the second one? It means 5 times 5 times 5 again. So really what we have is 5 times 5 times 5 times 5 times 5 times 5. How many 5s is that? 6. So you know what I'm going to ask you right now. How did you get this number, or how could you get this number without doing all this? If we just had the 3 and the 2, you would multiply them to get that. Power rule, multiply the exponents. No one's writing this anyway. Here's my exponents. That's the exponents. Okay, you got to multiply the exponents. I don't usually write quite this bad, Mr. Sinclair. Do I, students? I said, do I, students? Be nice to me. Okay, last question, or no, last 2 questions here. What's our base in this question? It is negative 4. And again, you're going to keep it in brackets. And then what are you going to do with the 4 and the 6? You're going to multiply them. So negative 4 to the 4th power raised to the 6th power is just the same as negative 4 to the 24th power. Now, I don't really want to cover this again, but Alexandra, I remember you were really good at this, so you're going to answer this one. Since it's negative 4 and it's raised to the 24th power, which is an even exponent, do you remember what that means? What could you also do? What could you write it here, make it just a little bit simpler? Something to do with the negative since it's raised to the even exponent? Alexandra? Alexandra? Okay. You got it, right, Alexandra? You can leave off the negative here, because if you have 24 negatives, negative 4 times negative 4 times negative 4, that's 24 times, it's going to become a positive, isn't it? So you could actually just write this as 4 to the 24th. But don't worry about that today. Okay, I just wanted to give Alexandra a chance to shine. Nice job. Okay, last one here. What's the base? 8, so we're going to write 8. And then we just multiply the exponents together. 6 times 0. Well, 6 times 0 is 0. Huh, 8 to the 0 power. Wonder if we could simplify that more. Yes, we could. Because I know you all remember, we're going to say it in unison. 8 to the 0 power equals... Okay, why did half of you say 0? That's not right. Why? What? I'm so disappointed. I hear I've been trying to teach you guys the whole year, and you're going to say 0 for this? Well... Thank you to the other half of the class who knows that the answer is 1. Alright, this is the end of the video. It's been a pleasure to teach you today. Alright, thanks again to Mr. Sinclair. Do your homework, do it in class so it's not homework, and have a great long weekend. Bye-bye.